hour and 30. 16. And 16. 14 minutes till 9. Another 16. Then an hour. Alright. Part 2, baby. So, we've covered some bullshit. Some class templates where I can have a struct that takes its own parameters so that the struct can be created from different things. And that totally is valid for points, maybe for vectors, for things where I need to have different versions of some basic thing. That way it accepts different information. Like an Unreal Engine where I add two numbers, we need a template that returns the sum, even if it's a float or a double or an int or anything. Okay. And for classes, we might need vectors where I sum 3 integers or I sum 2 integers into this. There's different little like things that I can make. But for defined things that I want to have specific pieces of it, a character has an inventory, which is an array of items. He's got another array of equipped items, armor, like armor equipped items, and then maybe so there's like equipped, there's held items, there's equipped armor, there's a backpack, that kind of stuff, which is an inventory of items maybe, or maybe it's one object that holds an inventory. We could have health, stamina, speed, all these different things, and I don't want any of those to be placeholder types because I know exactly the type of data that I want. Okay. But for databases and other stuff, then maybe it makes sense to do templates because we don't specifically care about what type of data it is. We want this one type of class to be usable with different data. I feel like the boring stuff uses templates. I feel like, what does John Carmack think? All right. C with classes. Do you see anything about templates? Debug build sizes. Gotcha. When you're moving things around and you've got all this extra stuff compiled. Well, understands it and doesn't break shit, I guess. Yeah, see, I think this makes sense. You make this for a vector or whatever the hell a hash map is. Is it like a grouping of pointers or something? I'm not really sure. Without having to worry about your main things being templates. Okay. Alias templates too. Okay. Let's just keep going backwards and then I can let's do here. Quiz me on all information covered in these learncpp.com chapters and sections. Questions numbered backwards. The last question being one first, and first being the max last number. Something like that. Okay, this was not. Why is it starting at 15? Bro. What the Okay, this is not it. I think I got the gnat, maybe. Okay, yeah. Alright, fuck that. Alright, do that. I'm trying to think of when I want templates. And I see them helpful for functions. I guess maybe there are different types of objects that we would want, like... Excuse me, I don't know. I feel like I would want distinct types still. Or distinct objects. Distinct structs. Okay. Oh. Okay. Oh. Don't know. Okay, let's do this. Cool thing about the Japanese language is how many syllables are you, or how many everything has vowels in it. So it just seems like it's more vowel heavy than English, and there's more rhyming going on because there are only 5 different like sounds. I'm really not sure. Well, it's not even change source code during compilation. It says that the compiler can change the code however it likes, as long as it doesn't affect behavior. I think that's the main definition. It might be observable behavior, but I think it's that. Class template is a class that uses type template parameters, like type name T. Not like type name T. Allowing for its creation with a variety instances to be created with different, well, compiler generate separate instantiations definitions for each unique set combination of data types. A class template is a class that uses type template parameters like type name T. This makes the compiler generate separate instantiations / definitions for each. Generate a separate instantiation definition for each unique combination or OL of the class. For each unique combination of data types, if instantiated objects are initialized with. We can explicitly specify the definition the compiler should create, or let class CTAD argument deduction, is it CTAD? Or let class template argument deduction CTAD deduce the types from initializers. Example, template, type name T, type name U. Vector, sure. Or struct vector. Let's do a third. Type name U, type name V. Struct vector. TX UY BZ. And main. Vector int vector 3 1 2 3 vector float vector 1.f 2.f, or I mean we could do 1.1f 2.2f 3.3f. Totally didn't put the brace. $69. Clear struct via struct name. Struct name. Data members. Data member type, data member 1. Data member of a given type, well, variable of a given type, value initialized. Access members via member selection operator. Operator dot, like my struct dot member 1 or via pointer or with a or via pointer to struct via my struct pointer member 1. 68. Convert an enum value. Pass the enum. Pass the enumeration value to a function. With a switch case that returns the matching standard string view for each case, or an invalid standard or an error standard string view for the default case. Scoped enumerations in their classes. Keep their enumerators in their own scope, which means access via the scope, well, via operator, scope resolution operator, or using enum name. These enumerate you every time. These enumerators do not enumerators do not implicitly convert to integers, nor can they be compared to enumerators. Well, can they be compared to? I don't think so. Wait, let's try. Enum class hero. Okay, whatever. Let's just say whatever. All right, fine. And then we make another one, class called class villain, hero villain. Okay. And then what if we say if hero is great is villain hero? Can't. Yeah, so they can't be converted at all. But what if this is now just a regular enum? Still cannot. Okay, cool. So it cannot be converted to other information. And then if we remove this, gradient less than 3 or 43, say that. Still does not implicitly convert. Okay. Unless statically converted to integers twice. i.e. well. Enum or otherwise. First. Unscoped enumerators. Enumerations. Enumerations place their enumerators into the scope the enum is contained in. Into the same namespace or global scope. They implicitly convert to integers and can be directly compared to other types because they implicitly convert to integers. I think that's most of it. Standard optional is an object that optionally is a class, I think, that optionally optionally holds a value. We evaluate standard optional via as a condition or via dot has value to see if it has value. Dereferencing it via operator dereference. If empty, well, if it's empty, dereferencing it to access its value via operator dereference yields undefined behavior. Using dot value throws an exception. Standard optionals helpful for solving the sentinel value problem, where we choose a value to which our function doesn't treat as an error code. Instead, we can not return a value, making it clear that function turned a failure, since standard optional was empty. 5. Passing by address means passing the address of the object L value of an L value via address of operator We pass addresses to pointer variables that are dereferenced to access the value at the address without copying the value at the address, which is expensive for class types. Okay. A null pointer is a pointer. Is a value that initializes a pointer for no value. So it doesn't point to anything. Alright, this part is so great. Well, a little speed to it too. Oh, good job, YouTube, if this is natural. Oh, this isn't real. Okay. Oh, it's a baby gnat. It's on the screen. Damn. It points nowhere. To nothing. Evaluating a pointer turns whether it points to null. Points to address, true, or null, or is null, false. Use null pointer. Assign pointers with null pointer before their pointees object is destroyed to prevent dangling. Excuse me. Always make pointers point to null pointer or a valid object. L-value reference is a binding to a modifiable L-value. Index. I want to mention the pointer stuff. References are not objects, while pointers are objects. References are aliases for the referent object they refer to. Referent. While pointers are variables that store hopefully valid object or null pointer. Address. Reference and pointees, the references and value. It wasn't fast enough. I'm not experiencing time slowdown. Whenever I listen to stuff, like I used to listen to podcasts and things at faster speed, like 1.5 or 2 times speed. And after I listen to people like that for a while, I get like this little like droning in my head. There's no sound to it, but it's like it's like plain noise. It's just there, and I feel like I can settle into it and just slow down. It's a really weird feeling, but it persists for like, I don't know, 30 minutes maybe. After I'm getting there actually. I'm like maybe a quarter of the way there. It's noticeable right now, but let me make this faster. We're only at 1.40. Constant value different. Oops. Differs from constant expression by forcing its function to it. This is so fast. This is so loud. Aim fast. Generating compiler errors if it is unable to. Is in a runtime only context or past not arguments that aren't constant expressions. Let's try that. Constant value do thing. Oops. Forgot it needs a type. Duh. Then we could have some runtime only stuff. Okay, so it can, and I guess the point is that it just can't contain, so this evaluates basically to just, I guess 4, wherever it's called. So this just straight up evaluates to 4 before this gets run. So that's actually not an example. It's just that if we instead said here that this calls print thing, but hold, I think it doesn't, I don't think it knows where it is. I'm expecting a compiler error. Maybe not though. Yeah, that's what I thought. Okay, cool. It's unable to, when called with arguments that aren't constant expressions, or oh, we got so much time. Nice, 55 minutes. It's not happening right now. Is this any good? Some AI slop. What is this? Oh. I'm always for giving music a chance though. I hate this static delay. There's always like a 4-second delay. Nah. Oh yeah, Creepy Nuts is the best. I'm so itchy when it's cold. My hand, like everything, I feel like I'm tingling. When it's called with an argument that isn't a constant expression, or it has code inside it that can't run. Like if we're calling standard character output in a constant val function. Or calling runtime only code in it, like standard character output. All const expression functions can evaluate at runtime if not called in a, if not required to, and the compiler doesn't decide to if not required to evaluate at compile. Well, I'll just split this up. Let me write this better. Const eval functions must evaluate at compile time and generate compiler errors if called with arguments that aren't constant expressions when calling runtime only code like standard character output in them. Excuse me. Const expression functions evaluate at compile time. Ooh, optimization bonus compared to runtime only function. If called in a context that requires compile time evaluation, like calling as an expression called in a constant expression. Well, called where a constant expression, well, as in expression in a constant expression, because one expression holds. Yeah, if we had, it's an expression where a constant expression is required. And if its arguments are constant, well, its past arguments are constant expressions. And if the compiler decides to optimize it out and evaluate it at runtime, even on a, well, due to other secret criteria. Those criteria aren't satisfied, it will evaluate at compiled or at runtime unless the compiler decides to evaluate it. Well, being nice. I mean, come on, I can do better than that. Evaluates at runtime if those two criteria aren't satisfied, unless the compiler decides to optimize it out and evaluate at runtime based on criteria I'm ignorant about. Probably due to the as if rule. Const expression function and 62. What do you mean when it's required? What do you mean when is it required? Well, I mean, I guess it's required if we call, well, sorry. Oh shit, so if it's calling Now what if we made it? Oh, it's cool here. Required when called by a const eval. When function is called by a const eval function or a const expression function we want to evaluate at compile time. Since calling a runtime only function generate a compiler error for the const eval function will render the const expression function evaluable at runtime. Delete disallows calls to the overload the function overload. Add equals delete after the signature and remove the function's body. To disallow calls to functions or overload or function overloads that include unwanted or that yield unwanted implicit conversions. I think that's all I know for now. What else would we want it? Or yeah, I mean that's it really. I think function template is a place or function that makes the compiler, well, placeholder function with template parameters, with type template parameters. The compiler will generate separate instantiations, specializations of it, one for each unique function call with its unique set of argument data types, order, type order, combination of data argument data types / orders counts. This lets us write one function that does something but handle multiple data types that are acceptable arguments for it, like adding integers, floats, etc. Easier to make one generic version instead of writing multiple overloads. But we can still write and disallow overloads if we want. Like, for example, let's say type name T void apply damage T damager. Apply damage from damager to damagee. And type name U. U damagee. Person who's getting damaged and the person who's doing the damage. Doesn't do anything to him, but it's actually fine. Sure, we could say, can I say maybe unused? Maybe. starting to see how long that image was going to be looping. It was forever. It was like 5 seconds. You don't need too many videos to make, or too much like, visual stuff for a music video. You just loop stuff. Have like a good 30 seconds and you're good. And what? Oh, maybe we don't want would apply, well, would apply damage. Well, let's say would apply damage. Character. I really don't want character ones. Character damager. Character damagey. So it's cool there. Oh wait, I didn't put the ending. Okay, apply damage. C, A. Boom. Excuse me. 58. Function overloading is making multiple versions of a function with one identifier that likely with similar, well, doesn't matter. So we can call one identifier, change the and just change the, or well, call one identifier and let the compiler call the right version by finding the which version best matches the call's arguments. This lets us call add float or add int without yielding implicit conversions. Or data loss. Also lets us handle the behavior differently. Maybe we want to delete disallow a version. Or handle logic different. Like apply damage with an integer to deal damage, but call it with a string and instead print the string. Both typedef and type alias are aliases to an existing data type, letting us use it with another keyword, like typedef int big bar, or using big bar int. Maybe could help clarity. It doesn't create a distinct type. So aliases of the same aliased type are comparable and assignable to each other. Which maybe we don't want and would better use a scoped enum for. Auto keyword makes the, well, lets the compiler deduce the variable's data type from its initializer, acquired initializer. For example, nope, Boom. Same for return types, where the returned data type matches the data type of the function's returned value. For pointers and references, type deduction via auto, not const, drops references and top level const. They might need to reapply const or reference to preserve them, or make a pointer const, or keep a pointer const. Implicit conversions occur when passing data of type A to something expected, to an object, or to assign, to be assigned, to assign, initialize, to or initialize an object of type B, including function arguments. 2. The compiler will try to convert the type A data to the value to type B, hopefully, but not always, preserving the result. Some conversions are safe, like numeric promotion, and some may or may not be, like numeric conversion. Numeric conversion. Some are disallowed. Brace initialization, direct list initialization disallows implicit nearing conversions. So in X 5.5 or 5.0 yields a compiler error. 54, standard current input is most easily checked by evaluating it as a condition. Honestly, this is cool, where I'm not getting questioned about every single thing. I'm getting a couple questions, and every night I can just keep on handling them. I don't have to do every single thing every single day. I like this more, honestly. It's probably good to go hardcore in depth sometimes, though. I need something crazy now. This song is fantastic. This one's pretty good. That's really good. I don't know if it's what I want. Oh, that's exactly what I needed. Alien ant farm. I just found them out the other day. Okay. Voting as a condition, or standard input fail. If it fails, check if it failed because of an UF character via standard character input UF, and kill the program. We'll abort the program. I'm saying abort because we're literally using standard abort. Abort because the user wants to kill the program. Otherwise, clear the error via standard character input dot clear. Then remove the invalid input. Or if it didn't fail, but standard character input dot peak isn't an inline character, remove extraneous input the same way by clearing the input buffer. That way. So the input isn't carried to subsequent, or isn't extracted. Well, to prevent extracting that unwanted input. 53. Assert is a shortcut to doing an if statement on a condition with standard abort for its statement. i.e. is a runtime shortcut. Well, I mean, it's runtime either way, but
You're okay. You're okay, honey. You're okay. You're okay, honey.
i.e. use it to check assumptions at runtime. Maybe ensuring the player doesn't go out of bounds, or that the player is indeed found, etc. in the game world, etc. Static assert does the same, but instead of standard abort, it yields a compiler error. If evaluating to false. Asserts are compiled out if and debug is defined via define. So keeping if statements the same spot, asserts, can be helpful. Catch the same error and handle it at runtime in release build runtime. Generate random numbers by the Merson Twister engine. Merson Twister, a pseudo random number generator, high periodicity, high distance between, high number of calls between identical responses, doing seemingly high random validity. Decent efficiency and other strong parameters I'm ignorant about. Or, well, attributes. $26 left? Yep. 27. Let's go. Create a Mersenne twister. Seed it with a seeded standard seed sequence to fully seed it and not underseed it. To fully, not underseed, seed it. Then call it from a standard uniform int distribution. To convert its return value to a desired range, integer range. What about, is there a uniform float? Oh, it is only in, okay. Guess you wouldn't want a float though. And you probably just get two numbers and then convert them to be floats and then generate another random number, but then just add that as a decimal and then sum them and do random stuff like that. See, the standard will initialize the standard seed sequence with standard chrono, steady clock, and standard random device. Strong random pseudo random seed.
Oh, criminal.
Switch follow through is the phenomenon where switch cases do not own code, but the statement does. So if one case's code executes and isn't terminated by a break or return statement or a keyword, then subsequent code in the switch in subsequent cases will execute. Fix it by including a break or return. Or add fall through to make it intentional and readable. In a loop, break exits the innermost loop, exits a switch statement 2, resumes control execution after. A do while loop is a loop that executes, then evaluates its condition to determine if it should continue executing. A while loop is a loop that first evaluates the condition, then executes only if true. Do stuff at least once. While true. And then while true, do stuff maybe once or maybe never. In this case, forever. Am I stupid? Oh, it just can't be here. Oh. Oh wait, okay, I was wondering why I was... Yeah, it just can't be there. It has to be inside a function. Both have to be in a function. 48. An inline variable is one that compiler will see and duplicate multiple definitions of. We use these not helpful for non-constant because those only exist one place in memory and in definition and are forward declared, elsewhere. Inline variable. Inline is helpful for mainly const expression. Well, really, const expression variables that are created at compile time. There he is. I think I poked him. I bruised him. The gnat. Ready compile time. So their definitions are needed in every translation unit they're used. So inline makes the compiler allow repeated compiler allow repeated. Well, if it's const though, linker find the variables and deduplicate them. We don't have a unique copy for each. A redundant unique copy for each file. Because the point there is that if they're const, even if they're global, if they're const or const expression, the linker doesn't see them. It gives them internal linkage. But making them inline gives them external linkage so that the compiler will say, hey, yo, mamacita, I see you exist here and I see you exist here. We don't need multiview, buddy. Non-const global variables are evil because they're changeable everywhere they're used, which is probably many locations, making making debugging difficult. Well, put them in namespaces and keep good track. If we really need a non-const global variable, like time. Static makes local variables be created at at runtime instead of at runtime, or instead of during their function during each of their function calls. Well, static makes local variables get instantiated at compile, or well, at program start, instead of only when the function is called. Well, their function is called. Their lifetime extends till the end of the program, called static global duration. So their value isn't lost until then, meaning it persists between calls. Scope is still the same, so they're only accessible in their function. Internal linkage means the linker can't see the object or function, while external linkage means the linker can. Things with internal linkage ignore the one definition rule. Well, go with const or static. Well, const expression variables or static functions have internal linkage, so they won't conflict with other objects in the same scope in other files. External linkage means the compiler will see the multiple redefinitions and yield a linker error. 6 more minutes. Make functions that are only used in one file. Static so they don't conflict, so the linker doesn't complain if other files share the same identifier. Variable shadowing is when an inner variable takes priority over an outer variable, the same identifier, forcing us to, well, making it impossible to call the outer variable, or more difficult, like requiring a global resolution operator to call globals that are in the global namespace. This occurs because the compiler prioritizes call to inner variables over outer ones with the same identifier, i.e. in main and operator. When used on two for an integer operands. Well, on two integer operands yields the binary integer where all bits that were true, that were set true in both operands are true, and those that weren't true in both operand are unset false. 0. Stay set true 1. Example in X and Y and Z X and Y 0 1 0 0 1 0. (42) Standard bit set creates a binary, or well, an object holds a binary, well, a binary integer object with a set length of bits. What? Bits. And comes with various member functions that let us access change bit values without using bitwise operators. Use well, is it or equals or equals and equals, or what is it? XOR? XOR? In X set, flip, or well, set, unset. Oh, clear, or flip bits. Bit masks that let us target specific bits. And equals sets because it turns on, keeps all bits that are already set as set, and turns on any that weren't set in our flag but was set in the mask. The opposite for and equals. XOR is like or equals, but, or well, it's like, I think it's, is it, it's like and equals, with not done before. Something like that. Stack allocation is fast, automatic, local. Stack allocation, automatic variables with limited lifetime, auto storage deallocate when block ends. Oh, so like the variables that we're creating, there's this new malloc heap. Delete or free. Dynamic. So is the heap the dynamic? Okay. The stack is down below and the heap is above. Stack, heap. Oh, maybe that's how that works. I figure global would be. Well, I guess global is created at runtime. Well, I guess they're all created at runtime. I'm not sure exactly. All right. As if, as long as it is observable behavior stays the same. Okay. Specify observable. Okay. Oops. Class templates are blueprints for generating classes with different types. Old. And it's only in 17 books. Explicit is rarely manually used. Meaning that we usually use the class template and then boom, that's it. We don't explicitly do it too. Well, wait, bro, what? I can't. Switch base, modern, let's string view. A default slash fallback is good practice. Oh, well, yeah, I mean, we could do a standard string view. Oh, I meant to do a C style string, not a string view. Whoops, my bad. Oh, I guess we could do either way, but. Makes sense right here. Yep. Access underlying value and throw an empty useful signal. Well, yeah, it's exactly what I said. That's my address. Not the raw address. Oh, I forget it's a pointer to the object, not the raw address. Yeah, that's true. By dereferencing the pointer. Yep, that's right. Okay, so we're passing pointers. We're not passing the literal address. Assign pointers with no pointer prior. We can do that because it doesn't exist at those times, I guess. Evaluating a pointer will detect nullness. Gotcha. References are. Hold on. And not objects. It's implemented via pointer. Yeah, there it is. Implemented via pointers behind the scenes. Which is interesting. They're like pointer literals, I guess, huh? Constantly eval. What? Some specifics. Always evaluate compile time. Errors does not. Tries to evaluate. Can sometimes be called at runtime, but that's exactly what I said. I just said it a little too crazy. Delete. Correct. Cool. Specialization syntax. Station. Cool. Using is the main. Type defs aren't. Well, yeah, we know that. As you stated, what's the point of saying fairly if you say as you said? It's like as you okayly said, and then I say exactly what you said, and then I say you only okayly said it. Hello? What you talking about, boy? Says avoid redundancy and crazy. Yeah, exactly. So we're not having to manually do something. Oh, we're talking about auto. Maybe. That's what I said. It prevented. And debug disables assert compile time. Not just. Oh, there's two. It's not just define and debug. There are two. There's also define and debug. Oh, wait, what? Oh, there's also exclamation and debug. Oh, okay. Yeah. Are you sure? Fall through, short, accurate. Good. Inline, let the multiple useful for constant expression. Okay. Clarify terminology. In the same scope. You can't just say same variable across translation units. But I mean, I guess you say that they're already unique if they're already local. Yeah, I mean, it makes sense. That's the point. It's allowing us to do it so that, well, but if it's const, where they normally wouldn't be disallowed, I would add that. Correct? Global is mutable state. Global is because it's mutable, it's changeable, it's dangerous. Maintenance, yeah. The phrase this sets is unclear. That to set, that to clear. Or that and the opposite. Set it to be the opposite to clear the one. Oh, and it's exclamation to do that. Okay, that's alright. I'll take it. Alright. Time for a little 45 minutes of Expedition 33, baby. So it is the caret. The caret is how we do XOR for bitwise shit. Alright, night.